This video, in case it isn't already clear, is about evaluating infinite limits and some algebraic techniques that you can use to figure these problems out. Let's start off with a fact. Actually, it's an example, but it's so important that I'm just going to call it a fact. The limit as x approaches infinity of 1 over x is equal to 0. This is easily understood from our definition of a limit. Recall that the limit as x approaches c of f is equal to L if we can make f as close to L as we'd like by getting x close to c. How close to 0 do you want to get? Within a millionth? Let x be a million. Note that this statement is also true if the numerator is any constant k and the denominator is any power of x. Let's use it in our first example. The limit as x goes to infinity of 4x minus 1 divided by x plus 10. If we wanted to work this out algebraically, we might multiply the numerator and the denominator by 1 over x. When we do that, the problem changes its form. It becomes the limit as x approaches infinity of 4 minus 1 over x over 1 plus 10 over x. As x gets large, 1 over x goes to 0, and 10 over x goes to 0 as well, leaving us with the limit as x approaches infinity of 4 divided by 1, or 4. Let's take a look at a second example. The limit as x goes to infinity of 4x minus 1 over x squared plus x plus 10 can be tackled in a similar way. This time I'll multiply by 1 over x squared over 1 over x squared. Notice that I'm multiplying by the reciprocal of the highest degree. This creates the problem the limit as x goes to infinity of 4 over x minus 1 over x squared divided by 1 plus 1 over x plus 10 over x squared. Once again, notice that most of these terms go to 0 as x gets large. Once I let these terms go to 0, I can see that this has been simplified to nothing but a 1 in the denominator. However, keep in mind that there is a 0 minus 0 in the numerator, so our limit is 0 divided by 1, or just 0. In another example, the limit as x goes to infinity of arctan, there's not necessarily a lot of algebra that you could do, so remember that you can always look at a graph. In our graph of arctan, we're reminded that there is a horizontal asymptote, actually two of them, and as x approaches positive infinity, we get closer and closer to the upper asymptote, which is at pi over 2. So, the limit as x goes to infinity of arctan is pi over 2. And this reminds me that I can ask you about limits as x goes to negative infinity as well. If I asked you such a question, we just approach the left-hand side and the other asymptote, so the answer would be negative pi over 2. In another example, we can look at the limit as x goes to pi over 2 from the right of secant of x. Once again, there's not a lot of algebra that we can do, but if we want to avoid looking at a graph, one thing that we could do is switching from secant to cosine. Secant is 1 divided by cosine. So if I want to know what happens as I get closer and closer to pi over 2 from the right, that's what that plus sign is about, I really need to think about cosine. And I know that cosine approaches a small negative number as we get closer to pi over 2 from the right, as you can see in the graph. And 1 divided by a small negative number is going to represent a large negative number. So this is approaching negative infinity. That is to say, it doesn't exist. Let's look at another example. The limit as x goes to 3 from the left of this fraction. If I imagine substituting a 3, I know that I'm going to get 6 divided by 0. Well, we can't divide by 0. So just think about substituting a number really close to 3, but a little smaller. It's going to be about 6 divided by a small negative number. So since it's a fixed positive divided by a small negative, I know that I'm going to approach negative infinity again. Remember that a problem like example 4 and example 5 can always be done just by looking at a graph and observing what's going on near the vertical asymptote. So these were some strategies that you can use to evaluate infinite limits. I hope they were helpful.